constant for proportionality. Alrighty. So let's take a look at some examples there. Let's pull up. I'm gonna share screen with you in a second here, but let me go ahead and pull up something dealing with that. Okay. All right, so let me share screen here. And if you have a specific example, give me that. Otherwise, I'm just going to go ahead and make up an example. All right. So let's say that you have a recipe that says, in order to make these cookies for every 1 cup of flour, okay, for every 1 cup of flour, you must use 2 teaspoons of sugar. Okay. All right. So if we were to go through and make a table, okay, so this is for 1 serving, okay, for 1 serving. All right. So let's say we want 1 serving, 2 serving, 3 servings, 4 servings, and then we want 10 servings. Okay. So flour, sugar. Okay. So for the first one, 1 cup of flour, 2 teaspoons of sugar. Okay. Now, if I want 2 servings, how much flour am I going to use? Put it in the chat. How much flour? Good. And then how many teaspoons of sugar? Good. Okay. So for the next one, I want you to give me both answers. For 3 servings, how much flour, how much sugar? Give me both answers together. Good. Okay. And give me the next one. 3, 6. Check that one. You said 4, 6. You said 4 cups of flour, 6 teaspoons. Check that one. There you go. Okay. So then we have 4, 8. Now the last one, 10. How much flour? How much sugar? Good. So what did you do to get 20? How did you get 20? I want to know, how did we get 20? So basically, I can give you any amount of servings. Okay. Multiply the amount of sugar needed in 1 serving by the amount of serving needed. Okay. So we wanted 10 servings times sugar. 10, that would be 10 times 20. But remember, I only gave you the serving. So for instance, if I want 11 servings, what do you do to find how much flour first? Just tell me how much flour. What is your answer for flour? How do you know? Good. How did you get 11? Okay. So basically, however many servings, it's a one-to-one relationship. However many servings, I need a cup of flour for each serving. Now, how much sugar will you need in this case? I want you to give me the answer and explain to me how you got that answer. Good, good. So the ratio is 1 to 2. So basically, your constant of proportionality in this case is 2. For how many cups of flour you have, you multiply by 2. So your constant of proportionality is 2 in this case. Okay. Let me know if you need if you want to see another one, or if you need it worded differently, or if you have one that you want to work. Let me know what you want to do next. I'm just pulling up something while you let me know what you want to do next. I can do another one. I'm just going to pull up some examples here to do. Seventh grade constant of proportionality. I'm going to pull up some problems on that. Let's look at some proportional relationships here. Okay. All right, here we go. All right, so we're going to take a look at one here. Okay. So let's take a look here. All right, if you have a question, you just join us, just put your question in the chat. So let's take a look at another one here on proportions. Okay. So here's what we have. This is the problem. Okay. Go ahead, read it. And then I'm going to walk through it. King, just give me a ready once you've read it and you're ready to begin. Just put in the chat ready. All right. So Andre rode his bike at a constant speed. That means he's riding his bike and he's not increasing his speed. He's not slowing down. It's just staying constant. Okay. He went 1 mile, okay, in 5 minutes. Let me ask you this, King. How many miles will he go in 10 minutes? How many will he go in 10 minutes? Good. Okay. All right. So now it says, which of these equations represent the amount of time that it takes to ride a distance of d miles? Okay. All right. So, King, for every miles, it takes how many minutes again? For every mile, how many minutes does it take? Good. So what about if I went 3 miles? What would it be? How many minutes? Good. Tell me how you're getting that answer. What are you doing? Well, tell me exactly though what you're doing. The ratio is 1 to 5, but when I said 3 miles, what did you do to the 3 to get 15? Your ratio is correct. Your constant of proportionality of 5 is correct. But what do you do to that 3 to get 15? And then I said, well, in 10 minutes, how many miles? Okay. What did you do to that 3 to get 15? Okay. So you multiply the amount of miles. Okay. You multiply not the number of miles. Okay. Let me show you again. Okay. Multiply the number of miles, not by the number of minutes. So here's what I mean. Let's do it again. If you go 4 miles, how many minutes is it going to take you to do that? Tell me that. 20. Good. Okay. So what did you multiply? 4 miles. What did you multiply? You're close. You said the amount of miles, but you didn't multiply it by minutes. We found the minutes. What did you multiply by? Every time you're multiplying by what? No, you multiply the distance, yeah, 4 miles, but by what number? When I gave you 3, you multiply by what number to get 15? There you go. In each case, you're multiplying by your constant of proportionality. That ratio you found 1 to 5, every time you're multiplying by 5. And that tells you how many minutes. So if I gave you 5 miles, okay, how many minutes is that going to be to do that? There you go. So each time you're multiplying the miles by 5, okay? So with that, which one of these shows that the time equals 5 times the number of miles? Which one? A, B, C, or D? Put your answer in the chat. Excellent. Okay. So you used your constant of proportionality. You gave me that 1 to 5. That's good. For every 1 mile, 5 minutes. Okay. So the constant of proportionality is 5. In the first example we did, the constant of proportionality was 2. You had to each time multiply by 2. Okay. Good work. So in that case up here, if we wanted to know how much sugar, we would say sugar is equal to 2 times F, okay? Because our constant of proportionality was 2, okay? If I have 2 cups of flour, I multiply by 2 to get 4 cups of sugar. If I have 11 cups of flour, I multiply by 2 to get 22 cups of sugar because my constant of proportionality here is 2, and that's when you told me a ratio of 1 to 2. Yep. For every 1 cup of sugar, of flour, 2 teaspoons of sugar. Down here, you told me that you have a ratio of 1 to 5, which is good. That means your constant of proportionality is 5. So each time we multiply the miles times 5. Good work on that. All right. I have 2 other people or 1 other person that's on now. Tamisha, if I'm saying your name correctly. If you have a question or something you want to see me work on, go ahead and put it in the chat. And King, while she's working on that, if you have any other questions, you can feel free to put that in the chat as well. Okay. All right. And I'll just wait for you to give me something else to work on. What grade are you, Tamisha? Let me know what grade you are, Tamisha. I got it. 6th and 9th grader. So take a look at this 6th grade or 9th grade work both. Any questions that you have, something you want to see, just put it in the chat and I'll answer. And I know you said okay to that. Oh, kindergarten teacher. Oh, you are busy. You teaching and the parent of 2 children. I know you tired every day. Okay. All right. So I'm just waiting here for you to give me something else. And King, you can get whatever ready, what you want to do next. Hmm. Okay. 6th grade, they're probably doing something with ratios or something or another. And 9th grade, not sure where they're at. I'm sure something with linear equations, probably slope lines. Oh, thank you, King. That's great. How do you feel, King? Do you feel like, because you did pretty well with both of them, and you wrote your ratio, it's just when you had that 1 to 3, 1 to 5, the 3 tells you the constant of proportionality, and the 5 was the constant of proportionality. So I think you did pretty good with it. Okay, Mama, when you have your sixth and your ninth grader, have them come with whatever questions they have. Like King, he didn't have a specific problem, but he said that he was working on constants of proportionality. So I was able to give him a couple, even if it's the topic or somewhere near. But the closest they have, especially if they have the exact problems, just have them come ready with those. Okay. Okay. So if there are no questions, then we're going to call it a night. Like I said, the best thing is to come with your questions and then I'll answer them live for you. Okay. Okay. I'll wait a second then. And I'll wait for you to put something in the chat there. If you're all set, Ken, you don't have to wait around for us. I'm gonna go ahead and wait for Mom to pull something for that sixth grader. Okay, dividing fractions. Let's look at this dividing fractions here. Okay. So would one example be something like maybe 3/4 divided by half? Something like that? Give me a yes or no on that. 3/4 divided by half, or is it mixed numbers? Give me some feedback. Is this what it is? I'll go ahead and work that one out. Okay. And then just let me know when you're ready or put it. Okay, he wrote down what I was doing. Got it. Okay. So first, let me just explain because keep, flip, and change, that's not real mathematics and it doesn't always apply. So let's go over what do we have here? Okay. So we have 3/4. And let's just review for a minute what division means first. Okay, so warm up here. If I give you 10 divided by 2, what's your answer? Put it in the chat for me. Good. Okay. So what that means is we wanted to see how many 2's can we get out of 10? How many 2's can we get out of 10? And when you're dividing fractions, it's not as pretty because these aren't numbers that we work with on a daily basis, but the same idea applies. We want to know how many halves can we get out of 3/4, okay? So 3/4, so that means this much. And I want to divide it by half. Okay. So now I want to see how many of these can I get out of this? Okay. So I can get one whole one, and then I can get half of one. Okay. Again, how many of these can I get out of that? Okay. How many 2's can I get out of 10? Okay. So if I had 1, 2, 4, 5, 6, 7, 8, 9, 10. How many 2's can I get? Okay, that's what I'm doing. Same thing over here. Okay. Over here, it's just that it's fractions. Okay, I want to know how many of these can I get out of that? 1.5. Now, let's look at the math of that. The math of that is, and here's what you should remember. So that keep, change, flip, that's not what you want to use. Let me type in the chat what you want to say. Dividing a number is the same as multiplying by its reciprocal. That's the language you want to use. Go ahead and copy that, write it down. Dividing a number is the same as multiplying by its reciprocal. You can screenshot it, take a picture, what have you. Here's what I mean by that. Let's go back to 10 divided by 2 equals 5. And I said dividing a number is the same as multiplying by its reciprocal. The reciprocal of 2, 1/2. Okay. That's 10 times 1, 10 over 2 is 5. Okay. So dividing a number is the same as multiplying by its reciprocal. So over here, dividing a number is the same as multiplying by its reciprocal. Let's come down here and do it in cleaner space. All right. Dividing a number, same as multiplying by its reciprocal. So that means 3/4 multiply by its reciprocal. So the teacher is using language that's not mathematics to describe this. That's not correct. But what she's saying is to change, he or she is saying is to change this sign, keep the first fraction, change this sign to multiplication, and flip this. But flip is not a mathematical term, it's the reciprocal. Now, once you have that, you can multiply the numerators. What's 3 times 2? Give me that in the chat. Multiply your numerators. What do you get? What's 3 times 2? And don't say what. You can say, excuse me. You can say, pardon me. You can say, can you repeat that? What's 3 times 2? There you go. In the denominator, When you multiply, what do you get? Good. Okay. So now you have 6/4. Okay. 6/4. 6 divided by 4. Okay. You can go through and you can do the long division. Okay. You can say 4 goes into 6 one time. And you have 2 left over. So that's 1 2/4, which is 1.5. And let me pause there and give you time, because if you have any questions, ask me. Okay. Another way, this is 6 divided by 4. 1, 2, 3, 4, 5, 6 divided by 4. How many 4s can I get out of that? Well, 1, 2, 3, 4. I can get 1 4, but I only have 2 left. So I was able to get it one time and 2 of the 4 I needed, which is again 1.5. Okay. So that is what you're doing with dividing fractions. This is the visual of what's happening. You're seeing how many halves can I get out of 3/4. Okay. I'm gonna walk you through one more, and then I want you to do the third one on your own. Okay. So let's say that we do, absolutely, we can do another one. In fact, we're going to do 2 more. I'm going to do another one with you, and then I'm going to have you do it on your own. So let's say that we're doing 5/7 divided by 2/3. Okay. First thing is, dividing a number is the same as multiplying by its reciprocal. So 5/7 divided by 2/3 is the same as multiplying by the reciprocal. Okay, that's your first thing. Then from there, I know you know how to multiply, okay? So you would do 5 times 3. And let me show you a thing if you're having trouble with the multiplication tables. You can come to this. This is Polypad. Let me type it in the chat. Okay. And also, once you know what to do, if you're able to use a calculator, it's okay to use tools, okay? It's okay to use tools. The important thing about flipping the second one, well, let me, okay, so A over B, the reciprocal of that is B over A. 5 over 2, the reciprocal of that, 2 over 5. Okay, the numerator and the denominator flips. That's what is meant by the reciprocal. Okay, so if I give you 1 over 3, tell me in the chat what's the reciprocal of 1/3. There you go. Okay, that's what your teacher is meaning by flip. Okay, let's try one more. I want to make sure you're comfortable with the reciprocal. Okay, let's say that I give you, first of all, put in the chat, how old are you? And then I'm gonna put in the chat how old I am. Okay, you're 12 and I'm 49. Okay. So your age over my age, okay, that's 12/49. Tell me the reciprocal of our ages. What's the reciprocal? There you go. So you got it. You got the reciprocal. Excellent. Excellent. Okay. So you got it. So let's come back to our problem here. So we started with 5/7 divided by 2/3. We know that dividing a number is the same as multiplying by the reciprocal. And you know, when you get to school, your teacher is going to say, keep, change, flip. And you know what she mean by flip is reciprocal. Okay. So your teacher's probably going to say flip. And we know that Miss Moore is saying that in mathematics, that's the reciprocal. So once you have this, now you can just multiply the numerators and multiply your denominators. In the top, in your numerators, what's 5 times 3? Give me your answer in the chat. Excellent. Okay. In the denominator, do what you need to do. Put your answer in there for me. Good. And I didn't tell you what to do, what you need to do. I just figured by now you know what to do. So you multiply across 15/14. That is your answer. If you get this far right now without simplifying it, you understand how to divide fractions. Now we can go through and make this a mixed number. This is 15 divided by 14. Okay, and I'm going to take my time and show you. 1, 2, 3, 4, 5, 6. Here we go. 6, 7, 8, 9, 10, 11, 11, 12, 13, 14, 15. I want to know how many 14s I can get out of that. Well, all these together, that's 114. Yep, there you go. We can get one, but how many left over? How many do we have left over when we take out one group? There you go. So you have one left over out of the 14 we need. 1 and 1/14. Okay, you're doing pretty good. Now I want to give you one to do. Let me know if you feel good, if you're okay with doing one on your own. Let me know if you are ready. All right, let's do it. So let's say that you have 7/9, okay, divided by, let's say 2/3. Okay. I want you to go ahead and work it out first, and then just tell me your answer in the chat. And take your time with it. You don't have to rush. Mathematics is not about being fast. It's about taking your time to think. And have confidence because you've been doing pretty good. Okay, so let's see. You multiply straight across. So tell me on my next line, what should I write first? We're going to take it step by step. What should I write first? Okay, we're going to do equal. Okay, on my next line here, like up here, okay, when I started, this was my problem, and then I wrote this first, okay? So remember, and I'm going to charge you with going back. Remember, dividing a number is the same as multiplying by the reciprocal. Do your reciprocal piece. Okay. Okay, so we write 7/9 first. And then what? What do I write right here? What's after that? After 7/9, what's my sign going to be? What operation? No, what happens? Dividing a number is the same as what? Okay, what do we do here? To dividing a number is the same as multiplying by its reciprocal. So here, and this is when the teacher is saying, keep your first fraction, your sign changes from division to multiplication, and then you take the reciprocal of the second fraction. So down here, what should my sign be next? What operation? There you go, multiply. And then what should this fraction here be? The reciprocal of 2/3. Remember, it's the reciprocal. There you go, 3/2. Now multiply across. 7 times 3. Good. 9 times 2. Excellent. I want you to do another one though. And let me review this with you. When you're dividing a number, it's the same as multiplying by the reciprocal. So your original number, it stays the same. From 7/9, 7/9, it stays the same. Your division sign becomes multiplication. And then you take the reciprocal of the divisor. You take the reciprocal of the second fraction, okay? You're hearing your teacher refer to this as keep, change. That means we're changing from division to multiplication and then flip, like how we flipped our ages, you take the reciprocal, okay? So if I were to give you 6/10 divided by 5/2, okay? Go ahead and do that one for me. Okay, and I want you to walk me through it. Tell me what I write down first. What's the first thing I write down? There we go. We keep our first fraction the same. Good. All right. What's next? What do I write down next? There you go. Excellent. And then what do I write? There you go. The reciprocal. Excellent. Okay. Excellent. I knew that you were going to get it before we left here. Now, you've been doing pretty good with the multiplication, so go ahead and tell me what's my numerator going to be when you multiply across. Come on now. And your denominator? Come on. All right. You just made my night. Excellent. Excellent. Make sure you're giving yourself a hand there, okay? You did fantastic with that. You got every piece correct, okay? And that's the thing with it. It just takes practice because sometimes when you're struggling with something, you become frustrated. You don't even want to deal with it. So that's why you always want to calm down, be patient, take it a little bit at a time, and then we want to make sure that we end it on a success, okay? So we're going to pause right there because you got it. And I want you to live in that moment with what you did. And so let me just review for you. Here, you basically said that dividing a number is the same as multiplying by its reciprocal, or as your teacher is going to say, you keep this first fraction, you go from division to multiplication, and then you flip the second fraction or take the reciprocal of it. 5/2, the reciprocal is 2/5. And you've been doing really well with multiplying. So you multiplied across and you got 12 for the numerator, 10 times 5, 50 for the denominator. Excellent work. Okay. All right. And just put in the chat, write that fraction for me. Show me what your answer is because you just did 12 and 50. Write your final answer as a fraction for me. Good. Okay. Let me know how you feel about how you did today. Good, great, okay, could have did better. How do you, there we go. Good. And you should feel good. All right, excellent. Mom, any thoughts? Check in with us. Let us know how you feel. Good. Have them practice and make sure that you recognize and praise the breakthrough, okay, because it's possible for everything, and the more breakthroughs that he start to make, the better he's going to do overall, because when you're constantly struggling, it just frustrates you more. And even when he's capable of doing something, he's so frustrated, like just even trying. But what he demonstrated tonight is that he is capable of doing whatever it is that we put in front of him. But we have to be patient, we have to take our time, and we have to allow him to learn things at his pace. Okay? All right. So, all right. Thank you all. I'll be back again next week, so feel free to. And look at King, you stayed there the whole time, King. That's excellent. All right. So and then what's your son's name, Tamisha? Oh, okay, Xavier. Xavier, if someone else is having trouble with that in class, I think you're pretty good now where you can help out, okay? And hold on to that confidence. I don't care if the numbers change. When you're dividing fractions, that's the process that you do, that reciprocal. Remember that reciprocal. Remember how we did our age, okay? All right, you all have a beautiful evening. Good night.